In this problem, a rock of mass 5 kilograms is dropped a distance of 1 meter onto a spring. The spring is then compressed by 2 centimeters, which is equal to 0.02 meters. This problem asks us to find the spring constant using the given information. In order to solve this problem, we need to understand conservation of energy and the 2 points of maximum energy inside the system. The first point of maximum energy is gravitational potential energy. This occurs before the rock is released when it is 1 meter above the spring and is stationary. During this time, gravitational potential energy is the only type of energy inside the system. This means that it will be equal to the total energy of the system. This is because of conservation of energy, and if at one point gravitational potential energy is the only type of energy in the system, then all the other energies added in the system during any point in time must equal this value. This max gravitational potential energy is equal to the mass of the rock m multiplied by the acceleration due to gravity g multiplied by the height that the rock is being held at h, which is also 1 meter. The second point of maximum energy occurs when the rock fully compresses a spring and then becomes stationary. This occurs at the bottom of the system, and this means that elastic potential energy is the only energy involved during the system. Again, because the spring is being compressed, the rock is not moving, and the height is now 0. This max elastic potential energy is equal to the total energy for the same reason that the max gravitational potential energy was at the beginning, because of conservation of energy, and elastic potential energy is the only type of energy involved. This elastic potential energy is equal to 1/2 times spring constant K, which is what we're trying to solve for, multiplied by the distance the spring is compressed in meters squared, or x squared. Again, because both the max gravitational potential energy and the max elastic potential energy equal total energy, we can algebraically say that the max gravitational potential energy is equal to the max elastic potential energy. If we substitute the formulas in for both equations, we get mass times acceleration due to gravity times height is equal to 1/2 times spring constant K times the distance the spring is compressed in meters squared. We need to algebraically rearrange the equation to get K onto one side so that we can solve for it, which is the objective of the problem. After doing this, we get 2 mgh over x squared is equal to K. And when the values are substituted, you get 2 times 5 kilograms times 9.8 meters per second squared times 1 meter over 0.02 meters squared is equal to 245,000 newtons per meter. And this is our answer.